Good day, viewers. This would be our another edition of video on triangles, and we are mainly focusing on triangles congruency rules, and also we will be focusing on some of the inequalities in triangles. And I will discuss here what do we mean by inequalities. We have already discussed, and then we will also continuing doing it here. So first of all, we will start with exercise 7.3, and this is what exercise 7.3 and exercise 7.3. Okay. Now we are starting with question number 1. This would be question number 1, and in question number 1 it says this is an isosceles triangle. ABCD is an isosceles triangle. ABC, there is no D here. So again, D is a point, and this is joined together like this. I must see in order to reach that point. So this is point D. Now A and D are joined, and which is extended to P. A and D is joined, and which is extended to P. Unfortunately, it should be and is extended to bisect P. Okay. Now, okay, we will do that, even though it not very proportionate. If I make it too proportionate, then I lose the space here. So I make it smaller. So what is to show? Show that there are a few. Number one, triangle ABD. Triangle ABD is congruent to triangle ACD, and to again a triangle ABP. ABP is congruent triangle ACP, okay, which means this triangle. And to show that 3 AP bisects angle A and angle D, and 4 is AP is perpendicular bisector of BC. So we have a lot of things to do, but don't worry. So let us see what is given. It's given that AB equal to AC, and BD equal to CB. Okay, that means these two are isosceles triangles. Okay, let us first take, how do I attack this problem? I should be first concentrating on this item number 1, if they are done properly. Okay, so in order to do so, let me take these two triangles. These two triangles means triangle this one, triangle this, and of course I will take the other triangle like this. This one is the other triangle. This one is the other triangle I will take. Okay, so usual procedure, triangle ABD, and this time is triangle ACD. Okay, only these two triangles. Here it's given AB equal to AC. This is given. Okay. So this is one side is given. Now you see AD is equal to AD because this is common. Okay, and BD is equal to CD. This is also given. So we have three sides, one side, two number, three number sides. Okay, so triangle ABD is congruent to triangle ACD by what? SSS axiom. Done? This one is done. Okay, so we have taken care of this point. Okay, now once I have done that, then I can show that angle BAP is equal to angle CAP. This is CPCT. CPCT. Okay, which means what? I am saying that this angle and this angle are equal. These two angles are equal. So one point is this, that AP bisects. So AP bisects angle A. So this is also done partly. This I have not yet shown that D bisects, but I have shown AP bisects this thing. Okay, since this is now done, and then I can come down here and show take a little bit of space, and now I will take triangle ABP and triangle ACP. So let us take those triangles, these two triangles. So here the same, again AB is equal to AC, that is given. And what else is given? AP is common to both. AP is equal to AP. This is given. This is common. And we have just proven that angle BAP is equal to angle CAP, right? This is proven. So that's why I didn't erase this part of it. So this is given. This we have already proven from here by CPCT. So what does that mean? What does that mean? That is easily, we'll give it to you, that triangle ABP is congruent to triangle ACP. So this is done. Okay, now what is this thing? These bisects, that is the only one that is remaining. So I don't have a choice but to erase. Let us try from this one. Now we have to, I have to do is to prove that AP bisect DP, or rather, which is bisects a triangle angle D. Okay, first what I have to say? First, that ADP points RDP are collinear. Because AD has been extended to P. Okay, since I have proven these two triangles are congruent, I have proven this, I can also take BP is equal to PC. Okay, BP is equal to PC, and angle APB is equal to angle APC. Okay, these two I can take. And because I have proven angle ABP is congruent to angle ACP, I have proven this congruency. So these will be all CPCT. This is all also CPCT. Congruent, corresponding parts of congruent triangle, corresponding parts of congruent triangle. So this I can easily do that. Okay, now let us now come to triangle. Okay, once I have said this, this means that DP bisects BC. So this is AP is a bisectors of BC. Now I have to prove that it is also perpendicular. Okay, this I have to prove. Now if I go to these two angles, angle APB plus angle APC is equal to 180, because they are linear pairs. Okay, if this is done, then let me go from here to start other possibilities. Therefore, I can write angle ABP plus angle ABP is equal to 180. Okay, because angle ABP is equal to angle APC. Okay, therefore 2 into angle APB is equal to 180. Therefore angle APB is equal to 90, which shows that is DP is perpendicular to BC. So this is also proven. This is a perpendicular. Only thing that is remaining, I have to prove that DP is also bisector of angle D. That has to be proven. So what is left remaining to be proven? Remaining to be proven, we will do it here. Remaining to be proven is that AP is also bisector of angle D. So let's try that. So for this I have to take two triangles. Again, let us take triangles DBP and triangle DCP. Okay, these two triangles I have to take. Okay, now we will take these two triangles as we have shown it here. So if you see these two triangles, so let us write down triangle DBP and on this side triangle DCP. Okay. Now if you see this, you can first of all you can see DP is equal to DP because it is common. Let us start with a common thing. This is common. Once we have said that is common, and BD is equal to DC. This is given because it has been said that DBC is an isosceles triangle. Okay, what else is given? it is also, we have proven BP equal to P, BP is equal to, we should write it the other way around, CP. Okay, that doesn't make any, but to be on this thing, B and P is there. So we have also proven BP is equal to CP. That is from CPCT, proven earlier, CPCT, proven earlier. Proven earlier. Okay, then you can easily write angle BDC is equal to angle CDP. That comes as CPCT. Okay, so that means therefore DP bisects angle D. So all the items here has been proven thoroughly, one after the other, to show all the 4 points that was requested here, that has been asked, or to ask us to show, that has been done here. So this completes our question number 1 of exercise 7.3. We will now go to point number. We will again now continue with exercise 7.3. Exercise, we will continue remaining here, 7.3, and this is question number 2. Question number 2, it says, this is an isosceles triangle, and it says ABC, and AD is its altitude. I hope you know what altitude means. Altitude is AD. So this is your altitude. Altitude. Altitude also has a lot of meaning. Altitude means height. So it exactly measures this thing of the height. What we have to show, that it's a perpendicular given. So that means from a perpendicular is drawn on BC. So this is given. So to prove, let us say to show what? 1, it says AD bisects BD. AC bisects BD. AD bisects BC. That is BD is equal to CD. Okay, so this is given. And so what do we have to do? Okay. And also given, this is an altitude, 2 that is given is angle ADB is equal to angle ADC, not ACD. ADC is equal to 90 degrees. And they are equal. So let us see. So this is, I'm sorry, this should go on the other side. This is to show bisect, and it is to show that I have done this, I should do it this thing, AD bisects angle A. Okay. So given, what is given? Given AB is equal to AC, angle BDC is equal to angle ADB. Angle ADB is equal to angle ABC equal to 90 degree. Okay, if this is equal to 90 degree, then this is an hypotenuse, HYP, and this is also a hypotenuse, and which are equal. Therefore, if I take triangles A, B, D and triangle A, C, D, means what are the two triangles I am taking? I am taking this triangle, hatch it properly. Okay, they are hatched. This is one is hatched. So I will hatch the other one too in opposite direction. So this is also done. So these are the two triangles I am going to take. So in this, okay, now I have taken not equal to. This is and. So let me write down and triangle ABD, and I will triangle ACD. I have HYP, that is hypotenuse AB, because this comes first. AB is equal to HYP AC. So I need to show only one side, which is AD is common to AD. So I can easily say now that triangle ABD is congruent to triangle ACD by right hypotenuse, right angle hypotenuse side axiom. None? This is pretty easy. If they are congruent, then I can write BD is equal to CD, that is CPCT. Okay, and angle BAD is equal to angle CAD, that is also CPCT. Okay, therefore AD bisects angle A. Okay, it's proven. AD bisects angle A, AB bisects angle A, and AD bisects BC. Those two are already proven. Okay, we will now follow with question number 3. Question number 3 of the same 7.3 exercise, and this says two sides and medium of one triangle ABC. So let us take one triangle. So read it very carefully. So this I have already said. So this triangle ABC, and it says and median. Now, what is median? You take this thing, the point joining the other apex with the midpoint of the other side. So what is median? Median, not median is the line joining the apex with the midpoint of the opposite side. So this we should understand and we should know this. So please study all the properties like altitude, medium of a triangle. If you don't understand that, you will not be able to solve this problem. So as soon as this is given, so this is in the given point BC is equal, okay, let's call it M. M is given, it is given BM is equal to CM. Okay, this is okay. I will continue further. And in that case I will draw the other triangle that it says. So this says another triangle is there, and I have to go through the same thing. This is PQN. Okay, I got little bit space, so I will draw it so that you know the meaning of medium also in a better way. So this is medium. Okay, so this is what I have drawn. Okay, it seems this is a little bit on the other side, so I will start with this. I will start it here so that it looks more representative. Okay, so this is your N, this is P, this is Q, and this is R. Okay, so this is median. So this is median, this is medium. So here is also Qn is equal to Rn. It's given. Okay. So what is to be proven? It is proven that two sides are of this thing are equal to, or is given. So let us write down here given, because this comes before. So what is given here? Given AB is equal to PQ, okay, and that is given BC. BC is equal to a QR. So QR, so this is QR. So this is equal to this. Whole thing is equal to QR, and AM. AM is equal to PN. What is now? This is given. This is all given. This is given. This is given. What I have to prove? I have to prove or to show. To show one, there are two things you have to show. You have to show triangle ABM is congruent to triangle ACM. No, not here, say PQM. PQN. Okay, PQN. And what you have to show? You have to show triangle, whole triangle ABC. ABC is again congruent to triangle PQR. Okay, first, what I have to prove? I have to prove this triangle is congruent to this particular triangle. Okay, let's check it. ABM is equal to PQN. This we have to prove. So let us continue doing that. Okay, what do we have? Again, we use your procedure. Write triangle on both sides. Triangle ABM. And this side you write triangle PQN. Okay. Now in order to do that, I have got one thing. AB is equal to PQ. This is given. Okay. And what is given? It is given BM equal to CM. So I can also write BM. Okay, no, I don't think I can do it that way because this is not the two. These two are different. What is given? Is given BC is equal to QR is given. BC is equal to QR given this point. I will divide it by 2. So half BC is equal to half of QR. Okay, half BC is what? Half of BC will be BM, and that is half of QR is equal to will be QN. So this I need to prove before I write it there. So I stopped and I proved this one. Because this is equal, half of them should also be equal, and so BM is equal to QN. So I will write BM is equal to QN. So BM is equal to QN, and it is also given AM equal to PN. AM equal to PN. So AM is equal to PN. So what is it? What we give? This is by this is also given, but by construction this is given, and this is by construction it comes in here. This is given. This is given. GIVEN. This is given. So I can write triangle ABM is congruent to triangle PQN. Triangle ABM, so one is proved. So this is proved. This and this is proved. Okay. Only thing, the other one is remaining. Other one is remaining. Okay, now we are going to start with the triangle ABC and triangle PQRs. That means the whole thing. So I will rub these portions off because this is no longer. I have used it in my previous presentation. Previous explanation of other part. Now the median etc. will remain because that will be also maybe useful to me. Okay. Now, since I had proven this triangle half and this triangle half is congruent, I had proven these two triangles congruent. I am again doing it because I had missed something. So I will now take also this angle and this angle, they are equal. So I will take angle ABC is equal to angle PQR, and that is by CPCT. Okay. Now, let's take the keep the hash sheet in so that we know we are coming from this kind of this one. Let's take triangle ABC and let us take triangle PQR. If I take these two triangles, I have been given AB is equal to PQ. PQ is been given. BC is equal to QN. BC is equal to not QN, QR. QR that is given, and I have just proven angle B equal to angle C, that is by again by CPCT from previous proof. Okay, now, so if that is true, then I can always say triangle, and this would be by triangle ABC is congruent to triangle PQR, and that is by which rule? Side, angle, side. So there is nothing. So this is done. This is very, very easy. You have to be careful when you have proven these and these two triangles congruent. You have to pick up that this side angle and this side also equal by CPCT, so that in the next proof of the whole triangle you can use this equality to prove congruency by SAS. So this is done. Okay, we'll now start with question number 4, and here it says are two equal of a triangle ABC. Again a triangle this is a triangle ABC. Okay, this problem for question number or question number 4, it doesn't give a figure, so you have to draw the figure, and it only says BF and CF are two equal attitudes of triangle ABC. So it has to start with BF. This should be BF and this should be CF. So why I have to draw it like this? So that this since they are altitude, this angle should be 90 degrees. So I should draw a thing like this one. So this is BF and this is CE. So it should be BE. Okay, this is BE and this is CF. Okay, they are equal. So it's given. So what is given? Given AB. No, it's not given. It's not given. This is of isosceles triangle. It only gives BF, BE is equal to CF. It stands good. Not a BF is equal to CF. BE equal to CF. And they are equal. And they are altitudes. So they are altitudes. They are altitudes. Okay, that means this angle and this angle are 90, this angle and this angle, they are 90. Okay, so how do I do it and what do I have to prove? I have to prove, to show, okay, let me write down. To show, it is already written, AB is equal to AC. This I have to show. So how do I work on these two? First of all, in order to show these two are equal, I can also, or it says it equal to AC because this is isosceles triangle. If AB equal to AC, that means I can also show that angle B is equal to angle C. Okay, now in order to show that, I see that I can. So we will first, in order to show that this angle this and this is equal, I will start with two triangles, and those two triangles are this triangle and the other one I will take up this particular triangle. Okay? Now, if you take this particular triangle, this angle is 90. So, let us write down this one properly in a proper fashion. This should be FBC triangle. Okay, I am taking this FBC and triangle EBC. Okay, now you can always see this is right angle triangle, this is also right angle triangle. I can write angle BFC is equal to right angle. Therefore, BFC, therefore BC is hypotenuse. Okay, in BFC. So in BFC is this thing. On this side, if you see, on this side you will see that BEC is a right angle. Therefore, again BC is hypotenuse. Therefore, in this triangle, hypotenuse BC is equal to hypotenuse BC. Okay, so I need one side. That one side is given CF, or I have started a FBC. So I will start with BFC. So this is, so I will start with CF. CF is equal to BE. Okay, so that means these two triangles are congruent. So that means these two triangles are congruent. These two triangles are congruent. So triangle FBC is congruent to triangle EBC. If this is triangle, then angle B is equal to angle C, that is by CPCT. Therefore, triangle ABC is isosceles, that is again AB is equal to AC. So I hope you have got no problem in understanding this. Always be sure, even though this is not given, since they are saying BF and BE, it should be on this side so that you get BC as a common hypotenuse. Okay, so that completes our question number 4. We have got only one question remaining, and that is it's similar to this one, and there is no. We are now going to start question number 5, which is last question in exercise 7.3. And this exercise is a little bit funny, but we will do it because it already says that ABC, this triangle ABC is already an isosceles triangle. ABC. So triangle ABC is an isosceles triangle. So if you say that, then AB equal to AC. Then it's redundant to say again AB equal to AC. And then it is asking to prove angle B equal to angle C. That is already proven if it is already an isosceles triangle. Anyway, for completeness, it says draw AP perpendicular to BC. draw AP perpendicular to BC to show that angle B equal to angle C. Okay, anyway, we will do that, and this is perpendicular, and to show AB equal to AC, which is already given. Okay, anyway, they want us to prove most probably these two triangles are congruent, but the wording that is used seems very funny. Okay, let's take these two triangles, like this. These two triangles we will take, and this is a 1 minute's job, and we will take the other triangle as this triangle. Okay, now, okay, this is perpendicular, so this is 90 degree. So I will write that this is hypotenuse. So this is this and this are hypotenuse. This is HYP, hypotenuse. This is hypotenuse, and I need one side. So I can prove these two triangles are congruent. So let us take triangle ABP is equal and triangle, sorry, not equal to, and triangle ACP. Since as triangle APB and angle, not triangle, this is angle APC are right angles AB and AC are hypotenuse, and AB is equal to AC. This is given. This is given. AB equal to AC. This is given, and AP is equal to AP. That is common. That is common. Therefore, from here to here, therefore, triangle ABP is congruent to triangle ACP. So, angle B is equal to angle C, CPCT. This is done. This is done. Simple. Even though this is, I thought they wanted to prove these two triangles are congruent, which is done, and this whole thing is over. So we have completed exercise 7.3. I would request you to go through all these on this series. This will be our 6th one in series, and you please go through all, because these will, and the congruency of triangles will be required in all. It will be required in quadrilateral, and any subsequent things you do, you will find that there will be requirement of congruency on triangles. So in our next video, we will be coming soon. We will be talking about inequalities in triangles, and we will be doing this is over. So I again request you to view all my videos in my channel, and please subscribe to the channel, and please like all the videos, and do a thorough study. This is much better than any videos you can see in YouTube or elsewhere, and also no book has will explain you in such greater details. Thank you and good day. Bye.